Okay, so let's talk about what the main idea here is in 5.1. We're going to be given some function. We'll assume that the function is positive for now. And let's say the function is defined from the interval from a to b. Then we divide the interval from a to b into n equal pieces. So each width is how long? Well, the full width is b minus a, and then if we divide it into n, we just have b minus a over n pieces, or each width is b minus a over n. Right, so if we had, in the last example, we had the interval from 0 to 1, and the width was 1 over n, right? Good. And so we'll go ahead and let a be equal to an x0, and then x1 is going to be the next one up, so that's going to be a plus our b minus a over n, which we'll call delta x, and then x2 is going to be a plus delta x, which is 2 times delta x, and then x3 is going to be a plus 3 shifts over, and so on until we get to x of n, which will be a plus n times delta x. And if we plug this in up here for delta x, we get that x sub n is just going to be b. Okay, so this is starting at 0 and going to n. Good. Now, so we have these endpoints here, right? x1, x2, x3, and so on. And this is xn. Okay, so now we have to decide if this is my strip going from xi to xi plus 1, where am I going to take my the height of the rectangle? And so we'll say we'll let xi star be the spot, or be the place on the ith interval where we evaluate the height of the rectangle. Now for the interval, for the example we had from 0 to 1, right? We used right endpoints. And so xi star is typically right endpoints or left endpoints, or you could do something else. You could take midpoints if you wanted to, or you could even take just random points. And that random point, I mean, you just select a point at random in the ith interval. Okay, and then you would evaluate the height at that point. Good. So the xi star then is the notation that we use when we don't want to specify where we're taking the endpoints, or not, where we're taking the heights, which endpoint we're taking the heights for. So again, it could be the left point, it could be the right point, it could be the midpoint, or it just could be some random point inside that interval. Good. And so now what would the area be? Area using n endpoints in our notation. Well, the width is 1 over, or b minus a over n. Shall I just use delta x so I don't have to write so much? So delta x times f of x1 star plus delta x times f2 star, fx2 star, plus, put some dots there, dot plus the change in x times f of xn star. Okay, now remember the delta x is here because that's the width, and then these are the heights. And so each of these terms represents the area of a rectangle. And so using our sigma notation, we could write that this is the sum from 1 to n of f of xi star times delta x. Okay. Now, in the next section, we're going to take a look at this more, and we're going to actually write down what these values are in terms of a and b. In fact, I'll go ahead and give you a little foreshadowing. On the interval from a to b using right endpoints, this is going to end up being f of a plus I times b minus a over n times b minus a over n. And so this is going to represent the ith right endpoint, and this is our width. Okay, it looks like some pretty funky notation right now, but you'll get used to it once you start plugging in some numbers from different functions. Good. Okay, so I think what we'll do now is just try a couple of examples from the book. So I'll pause here and I'll just write down a problem from the book. Okay, so this is number 4 in section 5.1. We'll estimate the area under the graph of f of x equals the square root of x for x between 1 and 5. And we'll use that using 4 rectangles. I forgot to say that. And either right endpoints, left endpoints, or midpoints. So the first thing to do when you're looking at these, I think, is to draw a quick sketch. And so in this case, our function looks like the square root function, and we're going from 1 to 5. Now, the length of this interval is 4, and so using 4 rectangles is going to be nice because that'll mean that I get to use the integers 2, 3, 4. So the width of each rectangle, no matter what type of endpoint I use, the width is going to be 1 unit. Good, and so that is equal to delta x in this case. Now, if I use right endpoints to compute my heights, what are the right endpoints that I'm going to use? Let's see if I can use the red. So the first right endpoint is going to be 2, right? And so if I draw a sketch of the rectangles that I use, it's going to look something like this, right? And so there's my 4 rectangles, and so the area for 1 will be square root of 2, so I apply my function, right, to each of my right endpoints. Square root of 2 times 1 plus square root of 3 times 1 plus the square root of 4 times 1 plus the square root of 5 times 1. And if we plug that into our calculator, we get approximately 7.382, and that is an overestimate, right? And it's an overestimate because our graph is increasing. And we can see that just from looking at the picture too. Left endpoints. What are the left endpoints for the 4 rectangles? Well, it's going to be 1, 2, 3, 4, right? And then that's the last one. And so the heights for those, let me draw those in purple. This height is going to be this. So this rectangle will be this high now. Then this one is going to be the second one I use. And this one's going to be the third. And this one will be the fourth. Right? And so you can see that that's going to be an underestimate. And so if we write down the 4 areas, then we get the square root of 1 times 1 plus the square root of 2 times 1 plus the square root of 3 times 1, so that's this one, plus the square root of 4 times 1, that's the last one. And so that's approximately going to be equal to 6.416. Good. And now, if you wanted to use midpoints, you could. Well, since it's being asked, we can. Um, so the first midpoint would be 3/2. The second one would be what? 5/2. This one would be 7/2 and 9/2. And so the midpoints are, oops, my graph is going funny. Hang on one sec. Okay, let's write down the midpoints that we're going to use or evaluate our heights at. That's 3/2, 5/2, 7/2, and 9/2. Good. And so our area then, using the 4 rectangles, and these as our heights, square root of 3/2 plus square root of 5/2 times our width, plus the square root of 7/2 times the width, plus the square root of 9/2 times the width, and that's approximately 6.79. Good. And so you can see here, this is probably the most accurate in this particular case. Good. So in this section, we're just going to try a few estimations and use we're going to try to find areas for nice shapes that have nice geometry to them. And in the next section, we'll deal with this notation a little bit more, where we dig into this idea. All right, see you then.